Yeah, guys. Okay. Sumant, is this fine now? My audio?
Yes, everything's fine.
Okay, let's start the class. Okay. Yeah. Hi guys, I'm Sunil. Today we'll speak about synchronization and deadlock. Okay. I think this don't have. Synchronization. Then we go for deadlock. Okay, guys. So basically, before going to synchronization, I want to give some layman example. Okay.
Okay.
Yeah. Suppose, like, let me remove everything. Let me open a new file. Yeah. So like, suppose there are, guys, there are some, you can say three rooms like that. Okay. You can assume these three are separate rooms. Okay, guys. Okay. See, all the three rooms have a common watchman, guys, here. Okay. Let us assume, they have a common watchman. Okay. What is that? Common watchman. Okay. So suppose the requirement here is, like, if you want to enter to any of the room, okay. If you want to enter to any of the room, you should get the lock. Am I correct, guys? Hello?
Yes.
So I'm saying, everyone, see here, we have a common watchman, and the requirement here is like you should get the lock before going to that. Am I correct?
Yes.
Yeah. So before going, if you want to go inside the room, you should have that lock of that room. Am I correct?
Yes.
So basically, these three rooms, let us assume, these three rooms have some common lock. Okay. So that lock is with that watchman. Okay. Suppose the guy A comes to here. Okay. He asks the watchman the key. Okay. Now the guy took the key from the watchman and he will go to this room. Okay. Suppose let us say this is a room 1, guys. Hello.
Yes.
So let us assume this is a room 1 and this is a room 2 and that is a room 3. Okay. So now the watchman will provide, suppose the person A came. Okay. Person A came. Now the watchman has provided the person A the lock. Okay. Now the person A enters to this room and he is doing his activity. Okay. See, he will come out once his activity is done. Am I correct, Sumant? Is that fine?
Yeah.
See, I'm repeating, these three rooms have a same lock, and that lock is with the watchman, common watchman. Okay. So when the person A came, that watchman has given a lock to this person A, and this person A goes to the room and room 1, and he starts performing his activity. Okay, like whatever he wants to cook, eat, sleep, like that. Okay, something like that. Okay. Is that fine so far, guys?
Yes.
Now, suppose in the issue, the meanwhile, some person B came. Okay, he want to access room 1, guys. Now he will go to this watchman and he will ask for the room 1. That watchman will say, wait, person A has already entered. You should wait until the person A comes out of that room. Is it making sense, guys? Hello, guys. Yeah, am I audible?
Yes, sir. Yeah.
I'm saying now person B, person A is doing his process. He's not comes out. Okay. Let's assume he was just eating. Okay. After that, he will sleep and he will come out like that. Okay. Suppose he is doing his activity. In the meanwhile, person B came for room 1 access. Okay. Room 1 lock. Okay. This watchman will reply that lock is with the person A. You should wait till the person A comes out of that room. Okay. Is that fine, guys?
Got it.
Got it. Now let us issue person C came. Person C came. Now person C wants to access room 2, guys. What is that? Person C wants to access room 2. Now he will go to the watchman and he wants the lock for room 2. Can the what watchman will say? Can anyone guess now? Will the watchman will say go and access room 2, or he might say something?
He might say something because there is only common.
Yes, that is the point. So there is only one lock, only common lock for all these 3 rooms.
Yeah.
Obviously, the room 2 is vacant. Okay, no one is executing room 2, but
Still
the lock is
lock
common.
with-
Yeah, the lock is common between all the objects, guys. Okay, na? The lock is common with all the objects. Okay, so person C has to wait. Okay, till the person A comes out of that room 1. Even that is room 2. Even if someone comes for room 3. Okay, room 3. See, let us assume, this room 1 is synchronized. So if you go to programmatic sense, suppose, let us assume each room 1 is a method. Each room is some method, guys. Okay, na? So you can relate the similar thing to that. Okay, suppose this room is identified by word synchronized. Okay, this room is also identified by word synchronized. Okay, I am saying all the synchronized methods or the synchronized rooms will have a common log, guys. Okay, suppose this room 3 is not synchronized, or if it has you can say it has some different log. Anyone can access. If it is not synchronized, okay, that method is not synchronized, anyone can access, guys. Guys, can you relate something?
Yes.
Any idea are you getting, guys?
Yes.
Is that fine? Gyapka, are you understanding, Gyapka? Are you following?
Yeah, అర్థమైంది.
అర్థమైంది కదా? So the thing is, if all the rooms has a common lock, whether the room 2 is vacant or or someone is executing it, you should wait till the room 1 will become empty. Okay, guys? Yeah. Now let us see. Okay. Now let us relate to our example. Okay. Now let us we'll draw the rough analogy. Suppose, guys, now my thread 1 extends thread, guys. Guys, this is one thread, guys. Class, see, if I write directly in Eclipse, you might confuse. Okay, just I'm writing roughly over here and we'll go over there. Okay, now thread. Okay, now class name. Okay, guys. Now we have a test, guys. Class something test. Okay, now what we'll do, guys? See, each class has a constructor, guys. My thread to test T. Guys, this is just our don't this is not that much complex, guys. This is just what we have done so far, what we have seen so far, guys. Okay. See, this is constructor, guys. Simple constructor. Am I correct, guys? Sumant, are you following? Hello?
Yes, Sunil.
See, this is my thread 1 and this is my thread 2. Okay, now. And this is my main class, some other thread. Okay, but I want to show my whole content with my thread 1 and my thread 2. I don't want to mix up main thread. Okay, now what will happen here? Tell me, someone. Suppose if I create object for test class. Okay, now I will pass this object reference T as a variable to whom? Both my thread 1 and my thread 2. What will happen, someone here? If I pass here,
It will call the parameterized function.
exactly. It will call the parameterized constructor. Now we'll map this T with this T. Okay, na?
Yes, because we can.
Yeah. So each class we have a test class reference variable, guys. This you can say my thread one has test class variable, test reference variable. My thread two also has test reference variable. Now we'll map this local to this global. Okay, how we'll map, Sumant?
Using that this keyword.
Yeah, exactly, this keyword. Guys, so far it is fine. Okay, now here also we'll do the same thing. Okay, na? Now after filling this test reference variable, we'll try to map what we have discussed on that layman example. Okay, na? Again, you can do the same thing here also. This dot t equal to t. Gap kya? Is it fine gap ka so far? Is this fine so far? Uh-huh. See, I am saying, yeah. I'm saying my question two is, you tell me now, if I pass this variable my thread one obj equal to new my thread one, okay na? Yeah. Okay, if I pass this reference of t, now what will happen in this line here? Huh? My thread one t reference. Can you explain it clear? Like I can't hear you properly. It will print the object of a t. That's my thread one. Here I'm passing this reference variable t so that it will call my parameters constructor. That you have to say, right? Sumant, is it clear for you, Sumant?
Yes, sir, it's clear.
It's clear, right? Okay. You see the recording again, okay? You're not following, yeah. See, this is just a core. There is no multi-threading concept, guys, here till now. Okay, this is just core Java concepts only. Yes, how can I increase the font size of Notepad, guys? Is this fine?
Edit, or you edit.
Edit tab. Okay. Font tab.
Font. Give some size as like 20.
Okay.
20 కాదు ఇంకేమి ఇష్టం 15 or 20, 16.
Okay, Antena? Is it fine? Can I go back or
Fine, go back.
save a contact?
House.
Yeah, it's fine, right? See, it's fine, that bit clear right now.
Yes.
See, this is my thread one obj1 and this is my thread two obj2, new my thread two, guys. Okay. Now I'm passing this t. Am I correct, guys?
Yes.
So this t will be assigned to this both test reference variables. Am I correct, guys? Okay, na?
Like what is the reason like you are passing?
Yeah,
like you have created the test.
I'm telling to that only, but
yeah,
till now it's fine, right?
Yes, it's fine.
Yeah, last class I have written directly. Yeah, I feel you guys have not understood properly. That's why. See, okay, now we'll have three methods, guys. Void add, something. Okay, void multiply, right? And void subtract, like that. Something. Okay. Okay, now. So if we call start method, guys, what will happen, guys? If we call obj1 dot start and obj2 dot start, guys. Come on. What will happen here?
It will like invoke the
Run method. Definitely. Exactly. Now we'll have a run method here. Okay. Jayshri, are you following, Jayshri?
She left. Oh, no.
Okay, fine. No, she will see. Okay. So, and here also will have a one more run method. Okay, that thread also. See, till now I have created two threads. Am I correct? And one test class. Am I correct, guys?
Yes.
Okay, na? Public void run. That. public void run. Okay. Now we from here, see, obviously this run will be executed by my thread two class. I'm a thread two. Am I correct? Suman, this run will be executed by thread one. Ante kada.
Yes.
Now from here we'll call t dot add method, guys.
Okay.
Okay. From here also we'll call t dot add method. T dot add method. Now let us relate our thing to what is that? Our layman example. Okay. Let us assume this add method multiply and subtract each method as a single root, guys. Okay, na? Now the main thing is, okay, suppose if you are calling some method, okay, like if you are calling some, see, basically there is no concept of locking until multi-threaded environment. Okay, na? So basically, if there is no synchronizer keyword, there is no concept of locking, guys. Now here the locking concept means if you are calling, suppose suppose here what's happening, this is thread one, guys. Is that correct? This the run method is executed by thread one. Ante kada?
Yeah.
Suppose in some thread you are calling the method with some object, okay, then you need to have that lock of that object, guys.
Okay.
Again, I'm repeating. Suppose in some thread flow, okay. Suppose either it might be my thread one or my thread two or main thread, whatever might be. If you in that flow, if you want to call some method with some object, you should get the lock of that object, guys. Okay. Hello.
Okay.
Now, suppose let us assume my thread one executes before my thread two. Let us assume. Now, if this t dot add is there, no, now you know this my thread one will get the lock of t object. Okay, now
Yes.
my thread one will get the t object and it can call this t dot add method, guys. Okay. Now you can say, let us take this method synchronized. Okay. So see, as the my thread one contains the t, t lock. Okay. T object lock. Because of that, it can execute this method, guys. Okay, na? So Sumant, is it fine till now?
Yes, sir.
See, I'm saying, just repeating. Suppose in some, see, let us say, suppose in some thread flow, you are trying to call a method on some particular reference variable. You should have that lock. That thread one should acquire the lock. Then only the thread one can execute that method. See, each room has a separate lock, Suman. See, not separate lock. All the rooms has a common lock. That's what I told, right?
Yeah.
See, all the synchronization methods in this test class have that common lock. Okay, that lock is nothing but the lock of the object.
Okay.
Okay, so I'm saying that, suppose if you want to suppose if this thread want to execute this add method, it should get the lock of that object. Okay, na? Hello, hello, I am in add. Okay. Okay, na? Suppose in the meanwhile, this second thread is requesting. Okay, this second thread is also coming to here. Am I correct?
Yeah.
Even it won't wait, right? Even it is also calling the same. It is also calling the add method on the same object. Am I correct?
Yes.
But unfortunately, the lock is with whom, guys? Unfortunately, the lock is with whom? Hello?
Yeah.
I'm asking. Yeah, unfortunately, the lock with whom, guys? Suman, I'm telling. Ramakrishna, నువ్వు చెప్తావా? No. See, what I told, my thread one has acquired the lock of this object T. Suman, see, see, I'll draw you some picture. If you're not fine, let me draw some picture. See, suppose, see, Suman, this is some common object. Let us take. Gold. This is something, object, common object. Okay, na?
Okay.
Suppose there are two threads. Okay, my thread one and my thread two are competing for the lock of this object. Is that fine?
Yes.
Suppose if my thread wants to call add method on this lock or any synchronized method on this lock, or any thread wants to call a synchronized method on this lock, then that thread should acquire the lock of this object and it can call that method. It can execute that method. Suppose this is T. Suppose this circle name is T. Suppose this my thread one wants to execute what is that add method, guys.
Okay.
Then that T should acquire lock of that, that then my thread one should acquire the lock of object T, and then only it can execute add method.
Okay.
Suppose I'm saying in the meanwhile my thread 2 came over here. It is also calling same T dot add method. But what I told, to execute this add method, already the lock is with whom, guys? My thread one.
Yeah.
So now my thread 2 should wait, okay, outside the method until completing by the my thread 1. Is that fine, guys?
Yes.
Yeah. Okay. So this is the, see, you can relate this thing. So what I told, suppose the person A has entered room 1. You can relate like the person A is nothing but thread 1. Thread 1 has entered add method. Am I correct, guys? So until and now person B is nothing but thread 2. Now thread 2 comes over here. Okay, thread 2 should acquire the lock of the room 1. But this room 1 lock is already with person A, thread 1. So until completing this, this function, this activity, that thread 2 should wait outside that room 1. Am I correct, guys?
Yes.
That's what I was trying to say here. See, this my thread 1 acquired the lock of that T object and it started executing the add method, guys. Now my thread 2 comes into picture and it is also requesting T dot add method. Okay, now now my thread 2 should wait till my thread 1 complete execution of this add method. Am I correct, guys?
Yeah.
Yeah. Is that clear?
Clear.
Thank you. Jay Sri, Gnapika, what about remaining people?
Sunil, I will go for recording 1 second.
Yeah, I'll share the recording. Okay.
Yeah, thank you.
Guys, Ramakrishna, is it clear?
Yeah.
Thank you. So now we'll see the example, okay, in the Eclipse. Okay, that example in the Eclipse. Okay. See, guys, you want me to create, each thread in a separate class or all threads in same class? Is that fine if I create all threads in same class?
Yes.
It's fine, right? Okay. So the code you have it's fine, right, Sumant? The code,
Yes. Yes.
the locking concept you understood.
Yeah.
Suppose, Sumant, let us assume, my thread 1 is executing the add method. Okay, now my thread 2 came and it is calling subtract method. So can you say, the subtract method will be started before completing the add method or no? Let us assume both methods are synchronized. These both methods are synchronized. Okay. Now, see, my thread 1 is executing this add method by getting the lock of the T. Okay. Now, can you say, just try this question, can my thread 2 execute subtract method as it is executing add method? Can my thread 2 will execute subtract method before completion of add method?
No.
No, because there is the all synchronous method has a common lock.
Common lock. That's why after
Exactly. So it should get, so that lock is belonging to the T reference variable. Okay. So it should get that lock of the T. Am I correct?
yes.
Okay. Guys, these cases are very, very important, guys. Okay. Na? Let us take my thread 1. Something from code, guys. Yes, this chapter is very, very important. Now, so but my question is, suppose there is multiply method. Okay. See, my thread one is executing add method, but thread two you are requesting multiply. So can you tell me this multiply will all instantly, or it should wait for the add method to complete?
Instantly. but
Yes,
it's not
because it's not synchronized, you can assume that this method does not require any lock.
Yes.
Okay, now only synchronized methods needs lock, guys.
Requirement.
Okay, na? That's it. Okay.
So this is the concept of locking. Like what?
Synchronized, yeah, exactly. Yeah, you can say this is the concept of locking. Is it fine, Suman?
Yes. Yes. So today with layman example, it feels bit.
It did great. Okay. In the last class, I feel like you guys direct
Yes, it's confusing really.
Yeah.
Like for us listening for the first time, it felt somewhat.
Definitely. Okay. Now, see, and we'll take a class test. Okay, na? Guys, how to increase the font of this Eclipse? Any idea, guys?
Edit. Go to edit.
Okay.
Just view is there anything? Bit,
But it's fine, right? At least.
it's fine. It's fine. No issue. We can get.
See, let us take the name of the thread which is executing. Okay. How to get the name of the current thread? Someone thread dot current thread dot
Yes. Current.
get name. Okay.
Current thread dot get name.
Okay. Now you can say let us assume that this thread requires some sleeping. Okay, he's doing some sleeping activity.
Thread dot sleep dot file.
Something okay, 2000 milliseconds. Okay, suppose if my thread 2 comes, okay, if it asks to JVM, like that thread is already sleeping, can you give the can you give the log to me? Okay, but it won't give. Okay, JVM will say I won't mind whether he's sleeping or whatever he will do. I will give only until after completion, after completed execution of the add method only, then only I will give the lock. Like that, okay? Okay, na?
Got it.
Get dot sleep. It should throw some exception, right? Like 1 minute. Why it's not throwing? Not giving error also. Yeah. Why it is not throwing exception? To save or what? Okay. I have mixed something over here. Yeah. 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 Now see, I have done some syntax error. Okay. See, now it is throwing it. So what will sleep method will throw? Which exception?
Illegal.
Last class also, I think I have asked the same question.
Interrupted exception.
Exactly. Join method or sleep method will throw interrupted exception. Okay.
Sometimes.
So this is a checked exception. Before you must handle either with the try catch or or bypassed by using throws. Okay. Otherwise it will throw compression error. Okay. Like how it shows. Okay. Na? Okay. Now you can say sys out. STR start execution like that. Is STR has started execution. And you can say sys out STR has completed its execution. Okay. Na?
Okay.
Okay. Now we'll copy the same method to subtract. Let us make. Okay. Guys, why I'm writing line 9, I want to make sure which method is executing that method, which thread is executing that method. Okay.
Yes.
So let us assume this is subtract method. Okay. Okay. Now that's it, guys. Okay. Now in this run method, so before yeah. So guys, see in this run method, if you want to call what is that? Add or subtract, I should have that reference, right? The thread key reference, right? Am I correct, guys?
Yes.
Guys, and both should call a common object, guys. See, you might get a doubt why you're passing that argument from main method to here and you're assigning in this constructor. Why these all things? Why can't we create a thread one thread, one
Directly.
thread object here and you can call directly, and one thread object here you call directly. But see, if you call like that, those two thread objects are become different, right? See, if we call some thread t equal to new thread here, and this again, if you wrote the same line here, those two thread objects will be different, right, guys? You got it, guys?
Yes.
So you should call on a single object, single reference variable. Okay, now, guys, is that fine?
Yeah.
So don't try like this. Okay, if you want to see really multi-threading, if you want to really experience multi-threading synchronization, then don't try like this. Okay, so you should create an object here. Okay, test t equal to test, and you can say my thread one. Okay, na? My thread one obj equal
Thread T, test T అంటారు.
ఏంటిది?
Line number 37.
Sorry. It is test t. Yeah. Okay, and here also some test t. Okay.
Yes.
Guys, why I'm doing right like this, because I want to assign a common object to both line 37 and line 44, so that you can experience multi-threading synchronization. Okay.
Yeah.
See, you should have a parameters constructor, otherwise it will throw you error. Okay, na?
Yes.
Okay, see, guys, now you can give the same way and you can use this. Okay, na? This dot t equal to t. Okay. Okay, guys, and here also you copy. Let us issue this obj1. I think yeah, guys, control plus only, easy thing. Guys, till now it's fine, guys.
Yes.
Thank you. My thread to obj2.
Copy చేసినావు కదా.
Uh,
Copy చేసినావు కదా పైన.
which one?
Nothing. ఆ లైన్ కాపీ చేసినావు కదా, డైరెక్ట్ పేస్ట్ చేసి thread to work.
Okay, right, David.
Yeah.
Now, if you see here, these two lines, 58 and 59, have you're passing same reference as a constructor, argument. Ante kada?
Yes, that is
So,
the reason నేను
that is the reason you can see from both threads, you are calling the method. You're from the my thread 1, you are calling method with the t, and my thread 2, you are calling method with the t. So then these two threads will compete for that object thread test object. Okay. Now whichever the thread acquire the lock first, they can execute that method. Okay, na? Is that fine, guys? See, now you'll just write test dot this dot t equal to t. Okay, na? That's it, guys. Now see, so obviously this class has that this 61 reference variable, and this class also has that reference variable. Am I correct, guys?
yes.
Now you call, okay, let us call T dot add and T dot, see, T dot add other, T dot add from here and T dot add from here. Okay? See, you are calling from two threads, you are calling the same method, guys, on the same object. Now I'm saying whichever the thread has the lock of that object will execute that first. Okay, that we can't decide, guys. Who will execute first and who will acquire lock? We can't decide, but we can say like which once some thread starts executing, okay, till the completion of that thread, no other thread is allowed to execute either add method or subtract method. Is that fine, guys?
Yes.
I'm saying again, once some thread started executing any of the synchronized method, and no other thread is allowed to execute the same method or some other synchronized method also. If it is not synchronized, that can access, guys. Okay.
Got
Okay. Now let us start. What is way around? Yeah, that's done. Let us run the code. Okay.
Yeah.
So this all thing comes under object level locking. Okay. What happened? You haven't started the start method or what? Yeah, sorry. I haven't called start method. Start. Start. Okay. Na?
Yeah.
See? See, guys, if you see here, thread 0 has started execution and it has given a gap of 2 seconds and thread 0 has completed execution. And then thread 1 started. It's not like in the between thread 0, thread 1 came into picture. It's not the case, right? Yes. Can you see this output? Okay, now?
Yeah.
Because this thread 0 is calling the add method on the same reference variable. Thread 1 also calling the add method on the same reference variable. Now I'm saying like the conclusion is whichever the thread has acquired the lock of that reference variable, okay, then that thread will be given a chance for the first. Okay, na? Once it is getting completed, then only it will okay. Some other method will it can execute. Okay, okay, guys, is it fine?
Fine.
Now let us try, let us call from one thread add method and one thread multiply method. Okay, what is that? Subtract. What we have? Add and subtract. Okay. See, now you can say I have plus add method. Okay. Let us, because I just want to make sure which method we are in. Okay. Okay. Now this is add. Okay. Na? Sumant, is it 5 minutes? Sumant, you know, 1 minute.
So,
Okay. Is it fine, right? Till now?
yes, Sunil.
Okay. Now. Yeah. So now let us execute again and we'll see, okay, the method clearly, once the method completes, like that. Okay. See, thread 0 has taken add method. Okay. First, okay. And thread 1, See.
It's taking add on the error.
yeah, because we're calling add method from thread 1 also. We're not calling subtract or other method. Okay. I think that we haven't changed it.
Okay.
See, add method, here also add method. Now see, but the thing is, you should understand like thread 0, once the thread 0 has done its execution, then only thread 1 has started. Am I correct, Sumant?
Done.
Then, now let us assume we are calling subtract from here. Let us take, we are calling subtract from here. Then also, once the thread who is getting the chance first, after its execution only, the other thread will start its execution. Okay.
Yes.
See, now thread 1 has started subtract after completion of add method by thread 0. Okay, now. Okay, now we'll take some non-synchronous method. Okay. Some multiply. Okay. Now it won't mind. Okay. Now that non-synchronous method will come in between. Okay. no thread will wait for this non-synchronization method. Okay?
Okay, it can come anywhere, like
yeah.
we cannot get
Because there is no
the-
locking concept here. Okay, I'll remove the synchronizer and I'll apply multiply. Okay. Okay. By multiply. Okay. Now you can see that multiply. Okay. Now this order won't come now. Okay. Ramakrishna, is it fine, Ramakrishna, till now? See, thread 0 has started execution. Okay, I haven't called it multiply method, right, from anywhere. Yeah. Let us call, instead of subtract, we call multiply. Okay, na?
Yes.
Okay, let's come back. See, something you can see some disturbance in the code. Am I correct, guys?
Yes, yes.
Okay, see this, once the thread 1 has started this multiply, but it is not, the thread 0 is not waiting for, because the thread 1 has not acquired the lock. Am I correct?
Yeah.
Now thread 0 has acquired, it's completed. Okay, now, okay, that's the case. Okay, now you can see some disturbance. Okay.
Yes.
Yeah, so this is about, synchronization and locking. Okay, now let us take, if suppose what will happen if T1 and test T2. Okay, now test T1 and test T2 equal to new test. Okay, now see, now one T will be, one type and second T will be T2. One T will be T1 and one T will be T2, right? Now see, the one, see, both threads will have separate locks. Both threads will acquire two separate locks of two different objects. See, this T is different now and this T is different now. Okay, now you can't, expect the behavior of synchronization now. Okay, guys.
Yes.
Okay, na?
So in this case, we can't expect like after
Yeah, obviously, because these two are separate objects, right? See, this thread is some different flow, and that is some different flow, and that will execute their method, and this will execute this method. So you
Yes.
can't expect synchronization. Okay, na? Is it fine?
Yes.
So much. See, I have just sending two different objects. Okay, na?
Got it.
See, let us call from add and I'll have subtractors. Okay. Now, you cannot expect the order, but if it might come, okay, you cannot assure that, but most of the cases it won't come in, it won't follow a proper order. Okay. Because both threads will execute parallelly. See, both threads have started and both threads have completed. It's not like one thread is starting and one thread is executing. Okay, na?
Yes.
See, this will come. Okay, na? So this is the concept, Sumant. Okay, you got it, Sumant? Today, it's clear. This is called object level locking. Now we'll have something called class level locking, guys.
Locking, we have
Yeah, this is
we have done with
object level locking. Okay, because see, one object has one lock, and each thread, the thread whichever acquiring that lock of the object, that thread is only executing. Am I correct?
Right.
Now we'll have something called class level locking. That is easy one. That is like, the method, suppose if there is a static method, okay, you're not, see, static methods, we're not calling with object, right? So we just directly call with that by the name itself. Am I correct?
Yes.
So at that time, there is no reference to object. So then how will that work? Means like, that is related to class level locking. Okay. Once the static method, which is started executed by some thread, the other thread should wait outside. Okay. Let me show that. Okay. Now this is class level locking, guys. Okay. So I'll remove this example. Okay. Na?
Yeah.
See guys, here we have created two separate classes and we have, we have created two separate objects. That is fine. But now with the same object, we'll create two different threads. Okay. With the same class, we'll create two different threads. Okay. So far, we have created two separate classes and two separate threads. Okay. Now I'm saying with the same class, we'll create two different threads. Okay, guys. Ramakrishna, is that fine? Hello?
Yes.
See, I'm saying till now we have thread one and thread two. Like we have created two separate objects for two separate, two separate classes. We have used the start method. Now I'm saying we'll do like, let us take this as a thread one. Okay. Let us assume this is obj1. Sumant, is that fine? You are very confident. Is that fine, Sumant? Today.
Sorry.
అర్థమైందా మొత్తం చెప్పింది?
Right.
అర్థమైంది కదా? That's fine. I'm saying you are very calm today. See, till now we have taken two separate my thread one and my thread two. We have created two separate objects for each class. Am I correct? Now you are calling you are making two different objects on the same class. Okay, na? Okay, we're calling both methods obj1 dot start and obj2 dot start. Okay, now from here there will be some static method over here. Static void check. Okay, na? Okay, so let us add synchronization. Guys, see, you are not calling this method with any of the object. Am I correct? See, this start method will call run method and just you're calling check method.
Yeah.
See, now this, because this is a static method. See, basically, if you go with the basics, so basically the static objects are static methods are static variables will be common across all the objects. Okay. So if once I draw the diagram, I will show you. Like I'm saying like what happened? Won't go around. See, I'm saying suppose this is object one. Okay, this is object two. So if you declare something as a static, that will be common to these two objects, guys. Okay, na Sumant?
Yeah.
So that is very basic. So try to relate something to that. So now you are not using any of the object, like you're not calling this method with any of the object. Okay, just you're calling directly. Okay, na? But this is called class level locking. Okay, this method will be executed by one thread. After the completion of that thread only, the other method will execute. Okay, na?
Yeah.
Okay, let us check that. Okay. And I don't want to write again sleep method and get name and set name. Just I will copy from here. Okay. So these are fine. See, Sumant, is that fine, Sumant?
Yeah.
So let us assume that this is a multiply or check. Both are fine, right? Check. Okay. Now we'll see. Okay. See, Sumant, last class I have missed the word static. Okay, that's why we have messed up in the last class. Yeah. Okay. See, guys. Okay. Sumant, is that fine?
Oh.
See, this
Yeah.
is very direct. Okay, you are not earlier there is a instance method. Okay, which will be present in some object. Okay, by using the same object from the two threads we have called. Am I correct?
Yeah.
Okay, that's why there is a object level locking concept comes into picture. Okay, the thread whoever acquired the lock of that object, that thread will execute first. Then after that, the second thread will execute. Okay, whether it will be same method or across the different methods. But required
Yeah.
thing is both should be synchronizable. Okay. Right?
Yeah.
So that is someone. Okay. Na? So this is about class level locking. That is about object level locking. Okay. Na?
Yeah.
So actually I thought of telling deadlock, but the time is up. Is it fine? Like if I teach that deadlock in next class?
Sure, sure.
Because this is, I think this is only a bit heavy, right? Today.
Yeah.
Yeah, I feel I can understand. But this is this is fine, and compared to last class, you have understood, I think, right? Compared to last class.
Yes, yes. Yeah.
Yes. Who is there in the class? Everyone has dropped. Jayashree only dropped. Okay. Okay. So let me stop sharing.